Hello dear friends, we shall be looking at the question we have on screen, guys. I got this question from the 2020 MIT B Integration B Qualified exam. It was a test for the people who aimed at participating in the 2020 MIT B competition. There are 20 questions and you have to answer for 20 minutes. Okay guys, let's get started. Okay friends, let's have the question. That's the question displayed on screen. Now guys, when you look at this question, what method of integration comes to your mind, guys? What do you think, guys? What do you think? Please pause the video and give it a try, then unpause it now to check the solution. Okay, now guys, when I first saw this question, guys, I was so terrified. But guys, I can tell you the truth that this question is actually very easy than you think, guys. Okay, let me show you how this question looks easy, guys. It looks easy in the sense that if you differentiate the bottom, guys, you're going to have exactly the top. Because if we want to integrate 1 over x minus 1, guys, it is no issue to us, right? Because it just gives us the natural log of the bottom. Okay, so guys, if we let our u to be the same as the series as k goes from 0 to 2019 of x to the power k, friends, keep in mind that this is a finite sum and not an infinite sum. Okay, it's a finite sum. So guys, in this case, the series as k goes from 0 to 2019 of x to the power k means that k starts from 0, k starts from 0 plus k plus when k starts from 1, and so on and so forth up to 2019. Okay, so guys, when our k becomes 0, now we are going to have our u in this case still being equal to, when k becomes 0, anything to the power 0 is 1. So we have 1 plus the series now as k starts from 1 now, guys, to 2019 of x to the power k. Okay, in this case, guys, if you differentiate both sides, we're going to have du to be the same as differentiating 1 gives us 0. Differentiating the series as k goes from 1 to 2019 of x to the power k, guys, we are just going to have k. Differentiating the function part, we have k multiplies x, then raised to the power k minus 1. Okay, now guys, at this point now, you see that we have just a series as k goes from 1 to 2019, right? Great. So friends, at this point in time, one thing we may want to do to make this our expression the same as the top is that when we look at the starting and the ending values, guys, we have 1 and we have 2019. 1 is more than 0, right? And 2019 is more than 18. So one thing that we may do to make things happen is that we are going to subtract 1 from these limits, and on the function, guys, we are going to add 1 to every value of k that we see. So if we do that, we have a du to be the same like the series. If we subtract 1 from 1, we have 0. Subtracting 1 from 2019, we have 2018. Then where we have k, we are just going to add 1. So we are going to have k plus 1. Then here we are just going to have x to the power k. Great. So guys, we see that this is exactly what we have at the top, right? It is exactly the top, guys. I told you that this expression is very easy. Okay, so now guys, in that case, now since we have it displayed in this form, it therefore means that this our integral now can therefore translate into the integral of 1 over x minus 1 plus this is our original integral being just the same as the natural log of the absolute value of the bottom, that is x minus 1, plus the natural log of just plus the natural log of the bottom, since the derivative of the bottom function here has given us the top. So we have the natural log of the series as k goes from 0 to 2019 of x raised to the power k. Okay, now guys, at this point it will be highly unreasonable for us to allow this series function into natural logarithm, but we are done, guys. We are done. Okay, we are done with the integration, but let's write it in such a way that it might look appealing. So we may want to picture the series as k goes from 0 to 2019 as a geometric sum. Namely, we are going to observe this series to be the general form of the geometric series, whose general form can be given as series as k goes from 0 to k of r raised to the power k, where in this case our r is the common ratio. And guys, this is a geometric progression series which can either diverge or it may converge. Okay, but guys, the sum of the first n terms of such a progression is given as Sn, where in this case our n is equal to k in this case. Okay, because this Sn is given generally in terms of n, but we have a k, and therefore means our n is the same like k of a into r raised to the power n minus 1 over r minus 1. So in this case now, guys, we substitute everything. We are going to have our series as k goes from 0 to 2019 of x to the power k being the same as our k in this case, guys. Keep in mind that our n in this case, which is the k, is what, 2019. Using this formula, our a in this case, guys, is 0, because when k becomes 0, we have 1, as you saw here. So our a becomes 1. So we have x to the power 2019 minus 1 over x minus 1. That therefore implies, guys, now this series is equal to this, right? We can come back into this, our natural logarithm, and substitute. If we do that, we are going to have just the natural log of the absolute value of x minus 1 plus the natural log of what we have. But guys, you can split this guy again. We can simply split it, and we are going to have just the natural log of the absolute value of x minus 1 plus the natural log of x raised to the power 2019 minus 1 minus natural log of the absolute value of x minus 1, since we are applying the quotient rule of since we are applying the quotient rule of the natural log function. So, but guys, what you notice is that the natural log of this function in blue is cancelling with one in green, right? At the end result, we simply have our answer being equal to a natural log of just x to the power 2019 minus 1 plus c. Great. So guys, thank you for watching the video. If there's something you don't understand, please leave it in the comment section down below, guys. I'll get back to you as soon as possible. Subscribe to my channel if you want to have more great content, guys. Like the video. It does motivate me a lot to keep creating more great content for you guys. Thank you very much. Have a blessed day.